Okay, in this lecture we're going to again talk about the operation of addition, subtraction, multiplication and division for functions, and then very importantly how to find the domains of these functions that are produced by these operations. Right, so the first thing is, what about f plus g of x? Well, we already know the definition of this is simply a point-by-point sum of the functions at each point x. So in this case it will in fact be x squared minus 3x plus 4x plus 5, which comes out to be x squared plus x plus 5. Okay, so that's how we do that one. Right, if we want to do the subtraction, of course, we know that this is f of x minus g of x. So this, of course, will be equal to x squared minus 3x. Now subtract 4x plus 5, and don't forget the parentheses here, and it's x squared minus 3x minus 4x minus 5, so this gives us x squared minus 7x subtract 5. And so that's our subtraction of the two functions. Now the multiplication, of course, we know is a point-by-point product. Alright, f of x times g of x, so in this case this will be x squared minus 3x, and we're doing that with the product of 4x plus 5. So we need to FOIL this out. Of course, we'll end up with 4x cubed plus 5x squared minus 12x so we have 12x squared actually, and we have minus 15x. Okay, so foiling it, 4x cubed, 5x squared, minus 12x squared, and minus 15x. So this becomes 4x cubed, subtract 7x squared, subtract 15x. So that's the product of the two functions. Now this one, of course, is simply f of x over g of x, as long as g of x is not equal to 0. So this will become, of course, x squared minus 3x divided by 4x plus 5. Alright, so that's how we do those. Now the important thing here is now to find the domains of these. Now if we look at the domain of f plus g, right, you'll notice here that what we have is a quadratic. We know that this is a quadratic, and we know that for quadratics we can determine the domain as being any real number, because I can square any real number, add any real number, and add 5 to get a real number. So this is clearly negative infinity to infinity. Right, next, if I want the domain of f minus g, right, again we come up here and we see that this is also a quadratic, so we're going to get exactly the same thing. If I now look at the product, right, if we look at the product, we have a cubic polynomial, and we can cube any real number, multiply it by 4. We can subtract the square, 7 times the square of any real number, and we can subtract 15 times any real number. So we don't have any restriction there, so that's certainly true as well. Now what about the domain of f divided by g? Well, we need to come up here and have a look at this and say, well, remember that we have this restriction. So we can't have 4x plus 5 cannot equal 0. So 4x cannot equal negative 5. So x cannot equal to negative 5 on 4. We can have any other value. Okay? And so consequently this will in fact be from negative infinity to negative 5/4, not including negative 5/4, and we'd need to combine that with negative 5/4 to infinity, again not including 5/4, and so we've omitted the 5/4, and this here will now be the domain of the function f divided by g.